8-4, multiplying special cases. Our objective is to find the square of a binomial and to find the product of a sum and a difference. And there are special rules that you can use to simplify the square of a binomial or the product of a sum or a difference. So squares of binomials have the form of a plus b squared or a minus b squared. You can algebraically simplify this product, or you can use an area model to discover the rule for simplifying a plus b squared as shown below. So a plus b squared, we could separate this into a plus b times a plus b, because that's what squaring something means, right? Multiplying by itself. So if we did that, and we used the distributive property or the FOIL method, we would see a times a to give me a squared, ab, ba, and then b squared. Well, ba is the same thing as ab because multiplication is commutative, doesn't matter which way I do it. So I can flip these two around, and now I have an ab here and an ab here to combine to give me 2ab. Okay, that's the same thing that our area model shows here. AB times AB gives me a squared, two of these things, two ABs and b squared right there. So here is our rule. The square of a binomial is the square of the first term plus twice the product of the two terms plus the square of the last term. And this is the thing that sort of everybody forgets if they're trying to do it quickly, right? You would see some people say a plus b squared. Oh, that's just a squared plus b squared. But we can clearly see that it's not, because we do have these two middle terms when I multiply a times b times a times b. If there's a plus, the middle term is positive. If there's a minus, the middle term is negative. So if you look at your examples here, we can just say x plus 4 squared is x squared plus 8x. 2 times x times 4 gives me this middle term, and then plus 16 4 squared. Or x squared minus 6x, because 2 times x times negative 3 is negative 6. And then negative 3 times negative 3 is going to be a positive 9 when you square it. So don't do this. Okay. Let's try a problem. Okay. What is the simplest form of each product? Let's take this nice and slow. We take the first term. We square it. Then we take 2 times the first term times the second term plus the second term, square it. Okay. Simplify this. X squared is just x squared. 2 times x times 8 is 16x, and then 64. Now, if the first term has two things in it, that's okay. Just be careful. You are going to square them both. Minus, because there's a minus here, 2 times 2m times 3 plus, or technically we would say minus negative 3 squared, but just plus 3 squared. Okay, so when I square 2m, that gives me 4m squared minus 12m plus 9. Let's try some guided problems. N squared minus 2 times n times 7 plus 7 squared to give me n squared minus 14n plus 49. This one with 2 in the front, just be careful. 2x squared plus 2 times 2x times 9 plus 9 squared to give me 4x squared plus 36x plus 81. Okay. Let's try a word problem. So a square outdoor patio is surrounded by a brick walkway as shown. So we have some bricks going around the outside here. the distance from side to side of the patio is x. This distance is 3. This is 3. So that's x plus 6. That's where that comes from right there. So the big square is x plus 6 by x plus 6. So if I wanted to find the area of the big square, I would go x plus 6 squared. Now if I want to find just the area of this piece on the outside, I would take this area of the big square and then I would subtract out that area. So let's minus the patio, which is x by x, which is x squared. Okay, well now I can use the technique that I just learned right here to square x plus 6. And again, if I wanted to, any of these problems, if I wanted to, I could always write them as x plus 6 times x plus 6 and then use the FOIL method. The point is to try to use this method of squaring a binomial just to make things a little bit easier. X squared plus 2 times x times 6 plus 6 squared, and then of course minus this x squared over here. X squared plus 12x plus 36 minus x squared, which cancels with this one to give me 12x plus 36. Okay, that's the area. Doesn't matter. It's got a variable. You know, what are you going to do? In problem 2, suppose the brick walkway is 4 feet wide. Okay, so then if this was 4 feet, now the distance for this length right there would be x plus 4 at the top and 4 at the bottom. So then it would be x plus 8 squared minus x squared for my area, which would be x squared plus, let's do this all in one shot here, 2 times x times 8, 16x plus 64 minus that x squared to give me 16x plus 64. Now, this technique can be used to square things in your head using mental math. You can square a binomial to find the square of a number. What is 39 squared? Well, I don't know what 39 squared is in my head, but I could easily square 40. Well, 40 times 40. Well, 4 times 4 is 16, and 2 zeros on it, so it's 1600. But I don't want 40. I want 39. So maybe I can square 40 minus 1. Okay. Well, like we just said, 40 is 1600 minus 2 times 40 times 1, which is 80 plus 1. And that answer, 40 minus 80 is 1520 plus 1, so that's 1521. If you were to use a calculator and square 39, you would get the same number, 1521. Maybe not super useful, but definitely, you know, handy if you ever need it. 85 squared. Again, we can go 80 plus 5 squared, or for the second part, is there more one way? Whoops. 90 minus 5 squared. Let's do 80 plus 5. So 80 squared is 6400 minus 2 times 80 times 5 is, well, 2 times 5 is, sorry, 2 times 5 is 10, and then 80 times 10, that's 800, plus 5 squared. This subtraction is pretty simple, right? 6400 minus 800 is 5600, plus 25 to give me 70 Yeah, 72.25, right? Yes. And same with 90 minus 5. Again, not the most useful thing, but you never know when it might come in handy. Okay, so next, the product of a sum and difference of the same two terms also produces a pattern. So if you have a sum and a difference with A and B both being exactly the same, when you FOIL this together, you get A squared, a minus AB, and a plus AB or BA, and then B squared. So these two are going to cancel because you're going to add when you add them together. So you now get A squared minus B squared when you multiply a sum and a difference of the same two terms. Okay, so the product of a sum and a difference of the same two terms is the difference of their squares. So A times B, A plus B times A minus B is A squared minus B squared. And we can see that here, that x plus 2 times x minus 2 is x squared minus 2 squared, x squared minus 4. Because the 2x and the minus 2x cancel each other out. So what is the simpler form of x to the third plus 8 times x to the third minus 8? If you notice that these two are the same and these two are the same, the only difference is the signs, we can use our technique of squaring the first term minus the square of the second term. Well, x to the third squared is x to the sixth minus 64. Okay. Let's try a few got it problems. Simpler form of each product. This is going to be x squared minus 9 squared, which is 81. Order doesn't matter here. These two are the same. These two are the same. The only difference is the sign in between them. So we get 6 squared minus m squared squared. So that's 36 minus m to the fourth. Even if there's two things in here, you just got to be careful to square both of them, right? So 3c squared is 9c squared minus 16. Okay. Again, if we so desired, we could use the rule for a product and a sum, a product of a sum and a difference to calculate products using mental math. So if I wanted to multiply 64 times 56, and I did not have a calculator, I could figure out what number is exactly in the middle between 64 and 56, and it is 60. So I could do 60 plus 4 times 60 minus 4, which would be 60 squared minus 4 squared. 60 squared is 3600 minus 16 to give me 3584. Okay. This works with any two numbers as long as they have an easy number to square directly in the middle of them. Like on our got it problem, 52 times 48. This is going to be, oops, this is going to be 50 plus 2 times 50 minus 2. 52 times 48. So that's 50 squared minus 2 squared, 2500 minus 4 to give me 2496. Okay. So simplify each product. This is going to be c squared plus 6c plus 9. 2 times the first term times the second term. Same thing here, g squared minus 8g plus 16. Let's do this one. That's going to be 4r squared minus 9, sum and difference. Okay, the middle terms cancel out. You just got to be careful that you square both of these. Square has a side length. What's the area? Well, it's a square, so all the sides are the same. And the formula for squaring, for area of a square, is one side squared. 4x squared plus 2 times 2 times 3, 12x plus 9. What rule would I use for number 5? I would use the rule I just did, right? Same as number 4. This is the product of a sum and a difference, and then this is 7x plus 2 squared. So the top two, or the first one and the third one, I would use the same rule. A squared plus or minus 2ab plus b squared. How do you know whether it is convenient to use the rule for the product of a sum and a difference to mentally multiply two numbers? Well, we talked about that a little bit. If you have a nice number that is directly in between the other two numbers, halfway in between, then it would be kind of nifty, or I guess kind of maybe a little bit useful to try the trick of adding a number and then subtracting a number and using mental math. Probably you're just going to use the calculator, but nice to know it's out there if you need it. And that was 8-4, multiplying special cases.